mostly you will see that some of them are very common. Some of these distribution you might have in fact already studied. Okay, so the first one is binomial distribution. Okay, second one is Poisson distribution. Okay, so these three, the first three you might have already seen. Okay, is exponential distribution. Okay, and number 4 Weibull. Okay, Weibull distribution, and number 5 is normal distribution. So whenever you are having a large number of data, statistical data in general, you can see that at least one of these distributions are mostly followed. Okay, so if we are basically having a standard way or standard pattern of data or results that we have. Okay, and so based on that we have it. So there are certain differences between the first two and the last three distributions, and this is probably what I'm going to list down now. Okay, so let me just write down some difference here. Okay, so it basically takes no okay no more than countable number of values, so you cannot have infinite number of values here. We'll just see it what exactly does it mean as we go on explaining these distributions one by one. Okay, more than countable number of values. Okay, this is one point, and this basically takes up discrete values. Okay, so this is discrete variable. Okay, okay, so I hope you understand something which you mean by discrete and continuous. Okay, in mathematical term, probably when we talk about something like summation. Okay, and you are going to take a value from, let's say, 1 to 4. We're going to take it for 1, 2, 3 and 4. Okay, we don't take any values in between, so this is more or less discrete in nature. If you're talking about something like integration and you go from 1 to 4, you are usually considering all the points between 1 and 4, so that can be considered as something which is continuous in nature. Okay, so a bit brief. Okay, and when we talk about this exponential Weibull or normal distribution, it's actually a continuous variable. Okay, so we basically have a continuous variable in this case. Okay, and I think you understand what is continuous. Okay, so just take the example of integration and summation, that should be okay. Okay, so these are the 5 kinds of distribution, and what we're going to do is we're going to take one by one. Okay, so let me just start with binomial distribution, and probably today we will just do binomial distribution. Okay. So you know, the term binomial actually suggests that there has to be only 2 kinds of results. Okay, so here it actually talks about 2 outputs. First one is binomial distribution. Okay. So we're just going to continue with this topic for maybe the next class as well. Okay, the distribution part. So it usually describes, as I said, discrete data. Okay, and by that we actually mean it will have only 2 results in a random experiment. Okay, only 2 results in a random experiment. So if you take up a coin and then try to just toss it, okay, and then you basically have got 2 outputs, either a head or a tail. Okay, and these are nothing but the 2 results that is possible. So these kind of observation usually comes under binomial distribution. Okay, so we can actually take some example, like maybe whether a student has passed or failed. Okay, pass or fail, that is as an example of binomial distribution. Okay, maybe a yes or a no, okay, as an answer will also come under something like a binomial distribution. We just take an example, and based on that we can actually look into it in more detail. Okay, and whenever we do some kind of notation, this is something which you might have already studied, because this is usually a part of physics syllabus. Okay, probability of success. Okay, P is the probability of success, usually denoted as that, and you know Q is nothing but probability of failure. So this might be a bit of revision for you, might have already studied this before. Okay, and when we talk about success, we know the failure by simply subtracting it from 1. Okay, 1 minus P. So 1 minus P is going to give you the probability of failure. Okay, And then in normal distribution, or sorry, binomial distribution, if you want to just find out what is the mean, okay, you can just consider n, the number of observation, and multiply it with p. Okay, and here we also have got the relation for standard deviation, and you need to remember these formulas specifically. Probably you need to make a table, and then you just need to remember what are the mean and standard deviation for each of these distribution. So that's npq root is there, just put the root. Okay, before that let me just write down this. N is the number of observation. Okay, number of observation. So if I take an example, I think this will be okay. So this part is actually nothing but it has a root, this root of npq. Okay, so please remember these. Okay, and if you are basically going to have any kind of binomial random variable, okay, so let's say x is a random variable. So I'll just take this example. X, okay, is a binomial random variable. Okay, so if that happens, the probability of getting x is nothing but factorial n, okay, divided by factorial x, and then factorial n minus x. Okay, so that's the value, and then you just multiply it with p to the power x into q to the power n minus x. So this is the formula that you should remember. I think you've already come across this, n minus x. Okay, so this is the formula for a binomial distribution. Okay, let's take up an example and try to solve. Okay, and let's see if we can get the important part of this particular thing. Okay, there is a condition that the condition, I think I should mention. Okay, maybe I can mention it here. Condition okay. The condition is each trial has two outcomes. Okay, so whenever you're looking into a problem, you just need to look into this as two outcomes. Okay, so if it has got two outcomes, the chances are that we are actually going to talk about binomial distribution. So please make sure you check that. Let's take up a problem on binomial distribution and then more clear. Okay, I'm not going to take too many examples, okay, because we are restricted by time. So let's say I have got a question on this multiple choice question are there. Okay, and there are 10 in number, so there are 10 multiple choice question. Okay, and then each has 4 options. So whenever you answer my questions in your test in your Google form, you're basically having that. Okay, you have 4 options. Sometimes I'm also giving you 5 options. The question is you have to find out the probability, okay, of getting no answers correct. No, okay, let me just put it within. That's the key term. Okay, no answers correct. So you're going to get a 0 in your exam. Okay, what is the probability of that if you keep checking randomly? Okay, so that's the question. Okay, so x is nothing but number of questions answered correctly. So now you see here, look into the formula and see what are the terms that you should know. First thing is x. This is your x. You put it here, you put it here, you put it here, you put it here, right? Probability of getting no answers correct. So that means the x value would be 0, right? So if x is 0, that means we can actually get the answer. But then let's find out what are the other values that we should know. First term is n, number of observation. N is already given to be 10 because there are 10 questions here. So n is 10. Okay. Next we need to know what is P and what is Q. What is P by definition is probability of success. So that's P. Now each question has got 4 options, and out of those 4 options only one answer is correct, and that keeps on happening for all the 10 questions, right? So the probability of success is basically 1 by 4, or you can just write it down to be 10 by 40. You answer 10, sorry, you have 40 options, out of which only 10 options are correct, right? So you can just simply write it down to be 1 by 4. So that's the probability of success, 0.25. And if you want to know what's the probability of failure, it will be nothing but 1 minus 0.25, and that would be 0.75. Now I think it's quite obvious, quite trivial. Okay, you just put the values and get your answers. Okay, so we need to find out what is P of 0, and then this will be factorial n, so it will be factorial 10, and that's factorial x, so it is factorial 0, and this is factorial of 10 minus 0. Okay, and then multiply it with p, so that's 0.25 to the power 0 into 0.75 to the power 10 minus 0. Okay. So now you can do your calculations, and if you do your calculations, the answer that I get is 0.0563. Okay, so this cannot be the answer, so you just need to check your steps. Okay, and if we just convert it into percentage, you have to just multiply it with 100. Okay, so you can just simply write it down to be 5.63%. So if I give you 10 questions, multiple choice question, each having 4 options, and you get a 0 in exam, the probability of getting that 0 in exam is actually only 5.63%. That means probability of not getting a 0 would be 100% minus 5.63. So 95% of the times you are not going to get a 0. Okay, so this is the beauty of binomial distribution. It tells a lot of gives you a lot of information. Okay.